Early detection of diabetic retinopathy is more important than ever. The integration of artificial intelligence with telescreening is transforming screening accessibility and improving patient outcomes, especially in remote and underserved areas. Now, to shed some light on the very topic, we have our very esteemed speaker for today, Ms. Brughanya Subramanian. She holds a bachelor's and a master's and is currently a doctoral researcher at the University of Tübingen, Germany. She's actively involved in cutting edge research in AI driven ophthalmic care, and today she'll share valuable insights from her work and experience. But before we begin, a few quick guidelines for all participants. Kindly keep your microphones muted during the session. You may post your questions in the chat box. We'll have a dedicated Q&A session at the end. Without further delay, I would like to invite Ms. Brughanya Subramaniam to begin her session. Ma'am, the virtual stage is all yours.
Thank you so much for the lovely introduction, Sajia. It was indeed a good and eventual evening. I hope it's evening in India, but then yeah, I really think that it is going to be an interactive session today. So yeah, should I start now?
Yes, ma'am. Yes, ma'am.
Yeah, sure. So is my screen visible?
Yeah, it's visible.
Is it visible?
Yeah.
Ah, okay, sure. Yeah. Before starting the session, I would like to ask, like, what do you know about AI? Like, you can give your comments in the chat box. Just, I want to know the audience's knowledge about the topic. So, quickly, you can give your answers in the chat box.
Okay, attendees, please interact. Put your answers in the chat box. Just overline of whatever you know about AI.
Yeah, it shouldn't be the right answer, but then, like, you can type in whatever thing that comes to your mind. Nobody is going to judge you here. So,
Yeah.
yeah.
Anyone?
You can also, like, say what are all the uses of the AI in ophthalmology. I hope all of them here are optometrists.
Yeah.
Yeah,
Okay,
that
we
would
have
be
our
great.
very first answer.
Yeah.
Ma'am, is the chat
Yeah.
box visible to you?
Yeah, it's visible. Yeah, I could see Ranjuta Bharati's
Oh, okay.
answer. Yeah. Awesome. That's awesome. Yeah. It's a human intelligence in infinite source. Wow, that's nice. Yeah. Everyone can answer, like, there is no right or wrong thing. At the end of the session, I hope, like, to deliver something that is, like, understandable for you guys. So I'm here to help you. So you can give in your answers, like, type. Come on, guys, you can type in your answers.
Okay, we have three answers so far.
Mhm.
Please interact because nobody is going to judge you. It's the basic question. Whatever you think, your perception of AI, give your perception of AI. What do you think about AI?
You've been, like, I think everyone is familiar with ChatGPT, so that is a form of AI. You can give in your answers like that. It's just a common thing, like, yeah, it enhances the diagnosis and makes easier to understand and provide more accuracy after humans approval. That's nice. It shouldn't be related only to ophthalmology, guys. Come on, you can give your, like, answers, whatever that you know about AI.
You can talk about the day-to-day tasks that you do. You'd use, I think everybody uses Gemini and ChatGPT on daily basis.
Yeah, that's true. Okay, I think it's done.
Yeah,
You can type in, yeah.
they are a little
I
shy.
mean, okay. Yeah, using biomarkers, that's amazing. Yeah, using biomarkers to help diagnose conditions in OCT, that's one of the area. That's true. Okay, now let's I think everyone is familiar with AI. Okay, we have another answer. AI is a machine that try to think, learn, and make decisions like humans. Yeah, that's true. That's true. That's true. Okay, now let's like. Okay, are we expecting any more answers? Okay, I think it's done. Okay, sure. So let me begin with the session now. So I think everyone is clear with the term AI and its uses in various fields, right? So now we'll look at the use of AI in diabetic retinopathy. It's more cross-sectional today, so let's dive into the session. Uh, okay, is my screen visible now?
Yes, yes, it's visible.
Yeah, sure. So we have had a brief interaction about AI, right? So now we'll, as I said, like we'll look into the AI uses in diabetic retinopathy screening. So
Now
which is
I
a
think
major thing in
presentation
India.
is not visible, I think.
Ah, is it?
No,
Just
actually,
is it not visible? Just a
have you
minute.
shared the screen? We can see your video right now, only your video.
Yeah. Is it visible now?
Yeah, yeah, now it's
Yes,
visible.
Yeah.
visible.
Yeah, sure. Thank you. So let's see what AI can do in diabetic retinopathy screening. Okay. So these are the objectives that we are actually like going to see in today's topic. So initially we'll discuss a few things about diabetic retinopathy burden in India, because I think majority of the people are from India, so I've like constructed this peer like presentation around Indian population. So we'll discuss that today, and then we'll explore the tele-screening models in eye care. So for example, like how this AI is helping in tele-screening camps and other rural areas. Uh, for the ease of diagnosis, and then we'll learn how this AI is integrated into DR diagnosis. So we'll talk about this in the future slides, and then we'll discuss how this entire telescreening is being incorporated into this primary eye care settings. And then finally, we'll discuss the challenges in the future directions of this AI in ophthalmology field. So before jumping on to the topic, I would like to discuss about why we need to like talk about DR. Because as we all know that DR is one of the leading preventable blindness, which is like present beneath myopia. Like myopia is one of the global pandemic, and after that, DR is one of the mostly talked about vision-related preventable blindness that could be avoided if we can take earlier measures, right? And this is most prevalent in India because like India is one of the uh, like well-known diabetic capital in the world, right? So we need to like keep more focus on this because there is a rising global diabetic prevalence in India, and this has to be like emphasized in earlier stages because like diabetic retinopathy when it presents, it often presents as an asymptomatic thing, which is a silent thief of your like vision, which is similar to your glaucoma. When a patient is coming to your clinic with a like initial stages of DR, like then they'll not be like symptomatic like myopia and all, like, right? So it is really important to take necessary measures in order to like detect it early so that the blindness could be prevented. So we can see what are all the current challenges in the DR screening, right? So basically, India is a highly populated country, right? So not everyone can have the access to the tertiary eye care setup, like AIMS and or like Shankar Netralaya, Bharati Vidyapeeth, and other like more specialized LVPI and other like tertiary eye care setups, right? So like in order to serve the people in the rural regions of India, we need to like bring more about like bring programs like telescreening and mobile unit to help them get access to the tertiary eye care treatments, right? So there is a huge load of patients in rural areas when compared to the cities also, so you need to like serve them as well so that we can prevent this diabetic retinopathy as a whole thing. And if we are like going to like do that, make them accessible to the rural thing as well, when the global pandemic diabetic retinopathy can also be decreased, right? So I would like to give a brief about what this telescreening. Everyone is talking about this telescreening and diabetic retinopathy and myopia pandemic. Everything is there. So what really is the telescreening? So I would like to break that down into two major portions. So initially, it could be divided into as a primary eye care method of preventing this entire global pandemic that is happening. We can, like, people not only screen here only for the diabetic retinopathy, they do like vision checks, they also screen for cataracts, they also screen for the other retinal conditions, right? So this entire tele-screening could be divided into two types, as I mentioned previously. So in the initial setup, there will be like caregivers like nurses and other camp organizers, something like that will be there. And then optometrists will also be in the initial step. And in the second step, there will be ophthalmologist who will be like guided, uh, sorry, who will be connected to the primary eye care setup with the satellite. I'll show you the images here. For example, like a setup like this will be given. So this is a mobile tele unit of the Shankar Netralaya's hospital. So you will have the entire ophthalmology setup inside this van. So what this van does is like it carries all the primary eye care vision screening tools in this van. So the people will from the tertiary eye care setup will go to the rural areas with the help of this van. They'll do the all preliminary primary screening, and then they'll like make the diagnosis whether to refer the patient or to not, okay, based on the severity of the disease. For example, in this case we are talking about diabetic retinopathy, right? Whether if it is a referable DR or not referable DR will be made at the campsite. And the in if in case if a patient is having a referable DR, that patient will be referred to the tertiary eye care setup. And in some cases, there is something called as this satellite connection, right? You can see there is a satellite connection. There is a doctor here in the tertiary eye care who's like seeing what is happening there in the campsite via this computer, right? If in case if some optometrist or other professionals who are there in the campsite couldn't make any like diagnosis of that particular disease, they'll be connected to the camera to the tertiary eye care setup via this satellite. Can you see the satellite here? Like you'll have this entire setup inside this van. So the fundus imaging will happen inside this van. So the patient will enter the van. If in case the optometrist is not able to make the proper diagnosis, then the fundus camera and the computer will be connected via the satellite, and the tertiary eye care setup will be having the access to access this van. So the doctor from the tertiary eye care unit will have the access to see the diagnosis, and then they'll be able to make a proper decision whether to like refer the patient or not. If in case if you refer all the patients, there will be a huge crowd in the tertiary eye care like hospital in the city, right? So in order to avoid that, the doctors in the hospital is going to like help the optometrist diagnose this in a proper way, and then they'll separate the crowd, right? So that the people in the rural area like will not be able to like travel. So this could be one of the huge helpful factor that can help them. Okay. So this is how the entire thing happens. So initially the patient will come to your camp. They will have this image acquisition with the help of fundus camera for the DR screening. And this data will be stored in the computer. And the AI inside the computer will help you grade the DR based on whether to refer that DR or to not. And it could be like finally validated with the help of optometrist who's present in that screening area. And then they'll be able to make an informed decision. I'll talk more about how this AI is helping in grading this entire DR in the future slides. So we have learned now about the telescreening setup, and we'll be like see how to implement this in real world settings. Like what are all the requirements that is needed in order to make this entire setup, right? So if you would like to set up this teleophthalmology unit, right? So you need to have trained staffs like optometrists, nurses, and van drivers and campsite organizers, and a proper infrastructure. Like you'll see camps happening in schools and common grounds and in apartments, right? So you need to have proper infrastructure and quality assurance. Like what is quality assurance is basically if you're like relying upon some, just in case if you are taking DR decisions based on this fundus photography, right? For example, in campsites you'll use non-midriatric fundus camera, right? So in that you'll have to like see the fundus camera. Certain fundus cameras will be helping you to like make your diagnosis whether to refer that case or not. So in order to maintain that quality assurance, an optometrist need to be present there to like to see that the AI is actually giving you the right on like decisions, right? In few cases, AI can also be like in wrong biased opinions. Like it can also give you a biased opinion. It would say that this is a referable DR, for example, like in early stages of DR, right? So that in order to avoid that, you need to like be present there and see the patients one by one in order to like refer them appropriately. So you need to have this basic setup if you would like to set up this teleophthalmology unit. And this could also be used in various other screenings. Like as I said, it can also be used in cataract screenings and other AMD screenings and whatnot. Like everything is possible with fundus camera. And then like, so I think everyone is aware about this AI in healthcare, right? So AI is like used in all the healthcare sectors right now, but we are right now interested in ophthalmology. And in ophthalmology itself, there are like glaucoma, cataracts, and corneal anomalies, and other retinal anomalies like AMD, diabetic retinopathy, and optic disc anomalies. Everything can be like diagnosed based on this AI right now. So we'll step into this one by one. So AI as a whole is basically a machine learning and deep learning. So machine learning is a broad spectrum. So this entire AI is basically machine learning, and deep learning is something that you train your AI. For example, like you will train your AI to make the right decisions. I will explain this in the future slides. So you will have an idea about what is really happening inside this fundus camera and what how it is actually giving your diagnosis. Okay. So this is AI in DR screening. For example, you will be able to see something like this in your fundus cameras. So I'll play this video. You can see how this AI is actually able to like diagnose the anomaly areas in the fundus camera and the fundus photos. So are you able to see my video?
Yes, yes.
Yeah, sure. So you can see that this is just an example. Okay, it is available online. So this is just an example how this entire fundus camera image is being screened. For example, this is orange thing is this area is your regular output of your fundus camera, but gr- this graphical region, the hotspots that you see here, are the areas that is being highlighted by the AI to point out that there is some anomaly present in this fundus photo. Okay, so this is how it is actually identifying the defective areas, and I'll explain more about how this is actually happening. Okay, so yeah, this is just to like give you an idea about how this AI is highlighting the defective areas in the fundus photo. Okay, so this is something this is a report that you will be able to like see if you upload a picture. For example, like if grade the DR based on the categories. If I upload a fundus photo to the AI machine, so it is going to give you something like this. So this will highlight the defective regions in the fundus photo, and then it will be able to like grade it. Okay, so I'll explain a lot in the next slides. So you can see that here there are no hotspots here visible, right? So it is classifying this as no DR and it is normal. And if there are any minute like deformities in the fundus photo, it is going to highlight that in the red spots, and then it is going to classify them based on the grading scales that has been uploaded to train. So now we'll look into the thing that how this AI is actually able to grade this entire fundus photo. Okay, so if you want, I can also like share this image afterwards because I'm not able to zoom in the entire image. So yeah, the thing is that initially you will have to like train the AI so that it is going to like behave as a human. So you'll be like giving a lot of retinal fundus images which is being graded by a trained professionals like optometrists and ophthalmologists. So basically, if you can say that there are 10 optometrists and 10 ophthalmologists sitting inside a room, they'll be having all the fundus photos, and they'll be like instructed to mark all the abnormalities of DR. Okay, for example, microaneurysms, dot blot hemorrhages, exudates, cottonwool spots, everything. So they'll be marking everything in a different color coding. Okay, so that marked fundus photo will be fed to this AI program. So for example, that will be like stored into this entire cloud. So that thing will be like processed with the help of AI, and then you'll get. So for example, if you're going to feed the retinal images, the first process is to like fundus image pre-processing, the AI pre-processing. So basically, in pre-processing step, the entire image will be analyzed by the AI, and then the pre-processing involves deleting all the blurred images and other artifacts and other defective images which are not properly marked by the ophthalmologist. So those unfit images will be removed in the first step. And the next step is to like convert this orange fundus image into grayscale, because this AI will be able to identify the defects better in the black and white grayscale, right? So the entire fundus images will be shifted to the black and white images, and then it will be proceeded to Gaussian blur. So this Gaussian blur is nothing but it is going to act as another pre-processing. So here the other like remaining artifacts and other blur, everything will be like removed, and then it will be proceeding to the next step, which is actually retinal feature segmentation. So this retinal feature segmentation involves marking all the abnormalities in the fundus. So you can see like I don't know if it is visible to you, but here in this fundus you can see that there is some abnormality being marked in the white region, and there is some small black abnormality being marked. So as I mentioned before, like each abnormality will be having a color coding, and that will be marked separately, right? So here the AI is going to uh, like basically going to segregate the retinal features, right? Mark the abnormalities, and then it will be like moved to the morphological operations. So the morphological operations is nothing but it is going to like complete the images. For example, in few fundus images, the vessels will not be like properly completed. So using the coding, the AI is actually going to complete the entire blood vessels. Can you see here? The entire blood vessel is being visible here. So both the veins and arteries will be like completed. So the image will be ready. Oh, sorry. So the image will be ready for analysis, right? So after segmentation, the next step will be image augmentation. So I know it is a lot. You can stop me anywhere so that I can explain it again to you if you're like not really following the flow. So am I being clear to everyone?
If anyone has a doubt, you can ask it right now, or else we'll proceed.
Okay, then. Okay, then I'll proceed. So the next step would be the image augmentation. So as the name suggests, the image augmentation is nothing but it's like extrapolating the data. For example, in your like bachelor's and master's, you would have done like case studies and other uh, projects, right? Like there are multiple kind of projects and things that has been happening. So there is cross-sectional study, there is cohort study, there is case control study. So this is something like a cohort. So cohort is something which can be done only in a larger group of population, right? So image augmentation is actually same. So AI can only be trained to become as a like effective diagnostic tool only if it has like huge amount of data. So if you give large amount of data, the AI will be like able to quickly identify the right diagnosis correctly and like appropriately, right? So this image augmentation is nothing but if you're going to give one fundus image, it is going to crop it, it is going to rotate it and flip it. So each type of like thing is actually going to build up and it is going to stack up, and it creates 10 number of images from one image. For example, if I give one image, it is going to rotate it, so that is a reading. And if it is going to flip, that is a reading. And if it is going to zoom, that is a reading. So all these readings will pile up to get a stack like thing, and then that will be like entering into the another step, right? So this is basically like extrapolating your data to create it in a larger scale so that the AI is able to like identify the diagnosis appropriately. So after image augmentation, the next step is to like retinal feature extraction. This is where your deep learning comes into play. So deep learning is something which is similar to your human brain. So in order to train the AI, you need to give a large amount of data so that the deep learning can learn what is retina, what is like vessels that is present inside it, what are all the exudates that is like happening, and what are all the abnormalities that is happening in DR. For example, what is dot plot hemorrhage, what is cotton wool spot, what is exudate. So it will learn everything from scratch. So this is the step where the deep learning is involved. And then after retinal feature extraction, it is going to go into deep learning based optimized classification. So after learning, so the next step is to like make the proper diagnosis. So here the DR will be like fully prepared to make the appropriate diagnosis. So if you are going to give a PDR case, the AI will identify that this is a PDR. Okay. So here the classification happens, and then after that you will get something the image, like this is the grad cam retinal image that I showed you previously. So here the hotspots, like the defective areas, will be like identified appropriately. So if this is a huge thing for you to follow, you can just remember these three steps. So for example, like you will have to like give the retinal image as your input, and after the neural processing, it is going to give you the diagnosis. Basically, it is like reducing your workload and helps you for screening faster and consistent grading. For example, basically reducing your workload and helps you for screening faster and consistent grading. For example, like if person A is grading fundus image as PDR and person B is actually grading it as moderate, there is a bias involved, right? But in cases of AI, there is no such bias involved, but it is actually going to give you the right thing when you ask it, like after and after, like that is called as the specificity. So the specificity of the AI is actually closer to the human thing, and it is also like helping us to make the quicker diagnosis and early detection also. So we have talked all about the advantages. Now we are going to like move into the limitations of this AI, right? So for example, I have said that AI cannot like miss any of such thing. It is like superpower, right? But AI can also make defects, right? And it is highly biased towards the train grades. I've said previously that all the optometrists and the ophthalmologists will be provided with a fundus image, right? And then they'll have to like grade everything separately. If there is any bias in that grading, then the AI result will also be affected. For example, you can see here, this is image A. So if a person is going to like mark this hemorrhage as a dot blot hemorrhage, this hemorrhage as a microaneurysm, and this microaneurysm has a hemorrhage, then there is going to be a bias, right? And person B should also like need to maintain the same method, right? So everyone needs to correctly like measure and mark it so that the AI output is also like giving a good amount of diagnosis. So yeah, it is highly dependent on the grader who is grading that. And also this is very time consuming. For example, it is easier in cases of like mild and moderate PR, but in cases of PDR, you'll have lot of data in one single fundus itself, right? So you'll have to like mark everything separately. You need to like mark the dot blot hemorrhages separately. Exudates, if there is a group of exudates, you cannot like mark them as a group. You need to mark them each of them separately. So that is in basically a lot of time involved. So that is one of the major limitations of this AI. So this is one of the paper that I found online. So basically here, the AI was like used for screening diabetic retinopathy at a community hospital in China. But you can see the accuracy of the AI here. So the color fundus photos were like produced by the fundus images, and they were all graded by the trained ophthalmologist. And you can see the amount of precision that the AI has reproduced here. It's like almost similar, like it has marked almost 90% of all the deformities here in the same pattern as which was provided to them. So it is like it also showed a like accuracy of 91.18% and 98.79%, which is almost closer to 92 and 99. So the sensitivity and the specificity was also like almost similar, like and like higher, in fact, like it is above 90%. So that is how accurate your AIs are. Like that is how it has been created these days. So with the help of these things, you can uh like basically like it can reduce your workload, and then you can do wonders with this AIs. So the other challenges that is actually like there with the AI is basically if you are producing, it is always quality dependent, right? Like if you are producing a like poor quality image, then the sensitivity on the specificity of the AI is going to like decrease. For example, in these cases, if you look at the picture B, the entire peripheral region is being blocked, right? So the AI cannot mark if something is here. So you need to help the AI so that the AI can help you. So it is a give and take policy. So basically, the image here is fully blurred, so you cannot see anything here. And the image GA, you can see there are many like areas which are normal, but the AI has marked there is something there. So this is also caused due to this artifacts like excessive bleaching or something like that has happened, and there is a lot of flash involved. So this is basically a poor quality image, and this can also give false positive and false negatives. So for example, like if you're like giving a blurred image like this, see there is no deformity here, but then it has marked that there is something there. So it is always dependent on the image that you're providing. So it has to be like really good images so that you can get a good results. And it also needs validation. So in cases like nothing wrong in giving this, but then like you will have to like sit and validate each and everything. For example, like there is some sort of hemorrhage here, I could see that, and the AI is also like detecting it properly, but then the grading can vary, right? So I need to be present there physically, so that I need to like cross check whether the AI is able to like predict the grade accordingly, like appropriately to that of the fundus image that has been given. Okay. Okay, I'll give you a minute to go through the key takeaways of the today's session. So with this, maybe I'll end the session. Thank you so much for this opportunity. So I can answer the questions if you have anything.
Thank you so much, ma'am. That was truly insightful and very informative presentation. I think it was something very new for all of us involved.
How was it?
Yeah.
Thank you.
So,
Thank you so much.
so if anyone has a doubt, put it in the chat box. We're
Yeah, of
taking
course.
questions now.
Yeah, thank you, Fatima. You can ask your questions if you have. I know it's a lot to take in. Maybe I can share my slides if you are interested, or you can always like contact me.
Let's give it a minute, okay? Okay, I think
Thank-
we have an attendee here who wants to share the screen, and he has an image to share. So, Sanjay sir, if you're listening me, you can share your screen. Until then, if anybody has a doubt, put it in the chat box. Okay, we have a question. Can we use or upload the fundus image and see? Is it open for everyone?
No, this is not an open AI like ChatGPT, because like these are all like having licenses, and it is owned by the separate research institute. So I don't think you can upload and see the fundus image creatings. But then like if you are from any of the educational institute, maybe you can see what are all the projects that they are doing so that they can help you access this. Because I think these are all like highly like privacy based things. So basically it involves patient's data, right? So there is no such thing as like open AI for this, unfortunately.
Mhm. Apart from this, if anybody has any doubt, you can obtain the certificate of attendance. We have shared a link in the chat box. Just click and fill up your details, and you'll get your certificate within 48 hours. Ranjita, close all the tabs that you've opened and retry.